Hello everyone. Today we will going to see some practice questions from the chapter Biomolecules. This is part 4. Let's start. Disclaimer. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the images. So we will see some practice questions from 25 to 32. Let's start with the question number 25. Identify the vitamin whose deficiency in our blood decreases reproductive power. So the question says that we have to identify the vitamin from the given vitamins in the option from which the deficiency of which in our blood decreases the reproductive power in the human. So options are vitamin E, vitamin D, vitamin A, or vitamin C. So you have some time to think about this question. After that, we will see the answer. Let's see. So the correct answer for the given question is option A, that is vitamin E. So deficiency of vitamin E in human being decreases the reproductive power. So when you have deficiency of vitamin E in our blood in the human being, so it will what it will cause, it will decrease the reproductive power. It will affect the reproductive power. And as our question asks that which vitamin decrease the reproductive power, so it is vitamin E, and thus our option A is the correct answer. Okay, moving on to our next question. The chemical name of vitamin B1 is. So we have to tell that vitamin B1 chemical name is what? So vitamin B1 is a vitamin of B group, B category vitamins. You have to tell the chemical name or the other name of vitamin B1. Options are ascorbic acid, riboflavin, pyridoxine, or thiamine. You have some time to think about this question. After that, we will see the answer. Okay, let's see. So the correct answer for the given question is option D, that is thiamine. So the chemical name of vitamin B1 is thiamine. The other name we called the vitamin B1 for is thiamine. And we have asked this in the question that the chemical name of vitamin B1. So thus we have a correct answer as option D, that is thiamine. Moving on to our next question. Which of the following is a fat soluble vitamin? So you have to tell that from the given options, you have to select one vitamin which is fat soluble. Okay, so there are vitamins which are either fat soluble or water soluble. So from the options, you have to select the vitamin which is fat soluble. Options are vitamin A, riboflavin, pyridoxine, or thiamine. You have some time to think about this question. After that, we will see the answer. So let's see. The correct answer for the given question is option A, that is vitamin A. Vitamin A, D, E, and K are fat soluble while all others are water soluble. So if you see on the category like fat soluble or water soluble, vitamin A, D, E, and K are come under the fat soluble category, while rest of the vitamins come under the water soluble category. Fat soluble means these vitamins are easily dissolved in the bodily fats in the human beings, while the water soluble means they can easily be dissolved in the water and then cannot be stored in the human body. So that those vitamins are water soluble. So from the given options, vitamin A is the vitamin which is fat soluble, and thus we have our correct answer as option A, that is vitamin A. Moving on to our next question. Adenosine is an example of. So we have given adenosine and we have asked that from the options choose the one for which adenosine is an example. Options are nucleotide, nucleoside, purine base, or pyrimidine base. You have some time to think about this question. After that, we will see the answer. Okay, let's see. The correct answer for the given question is option B, that is nucleoside. Adenosine is a nucleoside, while adenosine triphosphate is a nucleotide. So basically, there are two categories: nucleoside and nucleotide. Okay, so nucleoside and nucleotide are different from each other by just one phosphate group. Okay, so in the nucleotide, phosphate group is present. In the nucleoside, there is no phosphate group, only the base and the sugar molecule is present. Okay, and adenosine is an example of nucleoside. So it comes under the nucleoside category because of the lack of phosphate. While adenosine triphosphate having phosphate in it is coming under the nucleotide category. So we have asked that adenosine is an example of. So adenosine is an example of a nucleoside. And that is why we have our correct answer as option B, that is nucleoside. Let's move on to our next question. The base adenine occurs in. So we have asked that there is a base given named adenine. So adenine occurs in which structure? From the options, choose one. So options are only DNA, deoxyribonucleic acid, only RNA, ribonucleic acid, both in DNA and RNA. That means in like adenine base occurs both in DNA and RNA, or in the protein. So in which of the following the adenine occurs? You have some time to think about this question. After that, we will see the correct answer. Okay, let's see. The correct answer for the given question is option C, that is both DNA and RNA. That is both deoxyribonucleic acid and ribonucleic acid. Adenine is a purine base, okay, which is common in the DNA and the RNA. So adenine is a base which is a purine base, okay, which contain aromatic ring. So it is a purine base and it is common in both DNA and RNA. Okay, so you can found the adenine base in the DNA also and the RNA structure. Okay, so DNA has its own bases and RNA has its own bases. Thiamine and uracil are the one which are different in DNA and RNA. All the rest three are same. So adenine is one of them. Base adenine occurs in the both deoxyribonucleic acid and ribonucleic acid. And we have asked this that the base DNA occurs in what? So The correct answer is option C, that is in the both DNA and RNA. Moving on to our next question. The presence or absence of hydroxy group on which of the carbon atom of sugar differentiates RNA and DNA. So you have to tell that if you see the structure of RNA and DNA, at which carbon position, at which carbon position the presence or absence of hydroxy group decides or differentiates the RNA and DNA structure. Okay, so you have to tell the number of the carbon at which the presence or absence of hydroxy group indicates the differentiation. Options are first, that means first carbon, second, that means second carbon, third carbon, or fourth carbon. So you have to select one and you have some time to think about this question. After that, we will see the answer. Okay, let's see. The correct answer for the given question is option B, that is second. So this is the structure, and you can see that at the first position we have OH and H. First position means first carbon position. At the second position carbon we have H and OH. At the third carbon position we have H and OH. At the fourth carbon position we have H, and the fifth CH2OH group. Right, fifth carbon CH2OH group. So this is beta D ribose, which is a sugar base. So this is a sugar base. Okay, and the name is beta D ribose. It is used in RNA, and at second carbon you can see at the second carbon OH group is present, right? One OH group is attached. OH is also attached at the first carbon, third carbon, right? But here concentrate at the second position, that at the second carbon you have OH group attached, okay, in the beta D ribose, which is used in the RNA structure. While if you see the structure of beta D deoxyribose, which is also a sugar base but used in the DNA. So you can see that at the first carbon we have OH and H. At the second carbon we have 2H. At the third carbon we have OH and H, and at the fourth carbon we have H, and fifth carbon CH2H, right? So this is a structure of beta D deoxyribose, which is a sugar base, and it is used in the DNA structure. And now if you see at second carbon, that means at the position of second carbon here, the OH group is missing. You can see that two hydrogen groups are attached to the carbon placed at the second position in the structure, but in the beta D ribose structures, you have seen that at the second position carbon, the OH group is absent. The OH group was present in the beta D ribose, but in the beta D deoxyribose, which is used in DNA, we have absence of OH group at the second position. So that is why this structure, beta D deoxyribose, is used in the DNA structure, while the beta D ribose is used in the RNA. So you can differentiate between RNA and DNA by this concept that on the second carbon we have presence and absence of OH group. So we have asked that at which carbon the presence and or absence of OH group affect or differentiate between the DNA and RNA structure, right? So that is the second carbon. So at the second carbon, the presence and absence of OH group differentiate the RNA and the DNA structure. We can see that by using the beta D deoxyribose or beta D ribose structure, which is a sugar base which is used in either RNA and DNA. And you can see at the second position there is no OH group attached in the beta D deoxyribose, while one OH group is attached at second position carbon in the beta D ribose, right? So that is why we have our correct answer, that at the second carbon. Okay, let's move on to our next question. Which one of the following bases is not present in DNA? So we have given some bases name in the options. This question has came in JEE Means 2014, and you have to tell that which bases is not present in the DNA structure. Options are quinoline, adenine, cytosine, or thiamine. So you have some time to think about this question. After that, we will see the answer. Okay, let's see. The correct answer for the given question is option A, that is quinoline. So quinoline is an alkaloid and is not present in the DNA. Okay. So DNA has 4 nitrogen bases in adenine, guanine, and cytosine and thiamine. So we have asked that which of the bases is not present in the DNA structure. So the base which is not present in the DNA structure is quinoline because it is an alkaloid and it is not present in DNA. DNA has only 4 nitrogen bases, which is adenine, guanine, cytosine, and thiamine. The quinoline is absent. So from the given options, we have our correct answer as option A, that is quinoline. Moving on to next question. Directions. In the following questions, assertion A followed by region R is given. Choose the correct answer out of the following choices. So assertion A is given as all naturally occurring alpha amino acids except glycine are optically active. Reason: most naturally occurring amino acids have L configuration. So you have to select the correct option on the basis of assertion and region given. Options are assertion and region both are correct statements, and reason is the correct explanation of assertion. Assertion and region both are correct statements, but region is not the correct explanation of assertion. Assertion is correct and reason is incorrect. Both assertion and region are correct. So you have some time to think about this question. After that, we will see the answer. Okay, let's see. The correct answer for the given question is option B, that is assertion and reason both are correct statements, but reason is not the correct explanation of the assertion. That means we have given assertion that all naturally occurring alpha amino acids except glycine are optically active. This is a correct statement. And most naturally occurring amino acids have Levio configuration, which is our region statement. And this is also a correct statement. But the region is not satisfying the assertion. That means region is not correct explanation for the assertion. And that is why we have our correct answer as option B. So correct explanation, what will be correct explanation? Correct explanation will be that all alpha amino acids except glycine contains at least one chiral carbon. That is why all naturally occurring alpha amino acids except glycine are optically active. Okay. So this is the correct explanation because we have given assertion that all alpha amino acids are optically active except glycine. But the region is different. But region is not satisfying the assertion. The correct region or the correct explanation will be that all alpha amino acids except glycine are optically active because they contain at least one chiral carbon in it except glycine. Okay. And that is why we have our correct answer as option B, that assertion region both are correct statement, but the region is not the correct explanation of the assertion. That's all. Thank you.